Guys, I want to walk you through the multi-column structure for calculating present value, net present value, possibly even internal rate of return. I told you we would do this, and I would lead to helping you see how you might put this together for Cal Industries as part of the equity valuation assignment. But I'm going to start by talking about a company, a fictitious company, of course, by the name of Propensity Technologies that you see represented here. And Propensity Technologies has some no plat here in year 0, so that's the most recent year for which we have information. Has some expected rate of return of 8%. We are told that Propensity has an expected growth rate of their no plat or their income variable of 16% for years 1 through 10. And then beyond year 10, so years 11 plus, we're told to expect that it'll have a 6% growth rate of that income variable, again, being no plat. So I've put together a model here that does not include any values for year 0. So there's no investment value input into this yet. So this is not a net present value expressly. It is a present value equation that you'll see then how we morph that to a net present value as we go through. So first I'm going to show you Propensity Technologies without an investment, and then I'll show it to you with an investment. Then I'll show it to you side by side, without and with, and then finally I'll relate that to Cal Industries and let you also see how that relates to some of the different material we have going on in my solution set. So let's go back to Propensity Technologies. So when we're looking at this, here in this cell, you can see that we have the income variable at time 0, times 1 plus the increase of the income variable each year. And that gives us our income value then for the first year. We're going to do the exact same thing for the second year and every year thereafter through year 10. And you can see exactly how I got each of those each time. And that gives us the activity in the first cash flow column here. Technically it's the second column. My first column are the years. I think of this as the first because it's the first that has some real activity going on that's dynamic. In this next column, I'm simply taking the present value of the cash flow. And in this case, you can see that I've taken the value in cell F12 and divided it by 1 plus R to the T. And it's just exactly as you would take the discounted value of any cash flow variable. It's going to be divided by 1 plus R to the T. And in every one of the cells in this column, I do the exact same thing all the way down, even through this row 22 where we're talking about the continuing value. So separate out for a moment. We've got some explicit value taking place, or explicit period from forecasted period taking place here where we know what cash flows to expect, and we're finding the discounted value of them for each year, and then we're simply taking a running total of this. So when you look at this first year, I'm taking what was in the year 0 sum, I'm adding the year 1 amount to it and ending up with the year 1 sum. And I do the same thing for year 2. I take the new amount and add it to year 1, and I take the amount for year 3 and add it to year 2, for year 4, add it to year 3, and so on, until I get down here having taken the year 10 amount, added it to year 5, and year 9, and that gives us the value for year 10. Well, that's just the explicit period. That's the forecasted period that we have some confidence in that our numbers are correct here or have some bearing in reality. We know that beyond that, we have the continuing value. And in this case, we're using, for our continuing value formula, we're using the dividend growth equation, which is going to be some income variable at time 1 being the first year after the explicit periods last year, and that last year, that explicit period is time 0 in this construct. So some income variable in time 1, and we are then going ahead and making sure that we run the dividend growth equation, which in this case is going to be that income variable in year 10 expanded by 1 plus the growth rate for years 11 plus, and then we're going to divide that by R minus G, or G4 minus G6, which is R minus G. So that's the P0 equals D1 divided by R minus G, the perpetuity equation when the growth rate is different than 0 and when we can separate it from the expected discount rate or rate of return. Well, we know that that number lives out here in time 10, because that's when P0 lives, is at the last year of the explicit period. And so we want to discount that back, and I do that in this next cell, such that we're now looking at the income variable that we have in the continuing value, and we're dividing it by 1 plus the discount rate to the number of years, in which case the power of the number of years, which is the power of 10. And then to find the actual value, if you will, we're taking and adding up the value of the present value of the discounted cash flow plus the present value of the continuing value, and that gives us some value. That's a present value. It's not a net present value, because notice that I didn't put any possible cost in here, so I have no net to think about. Also, since I haven't put a possible cost in here, I can't think about an internal rate of return. So that might be a bit problematic for me as well. So that's how I would construct this, and this is no different than I showed you on the board in class. Now, if I was going to include a possible investment in the company as though that's what it cost me to get involved, I can put that into year 0. And everything else here, all the rest of this spreadsheet, is virtually identical in construction to the one we just looked at a second ago without the investment, except for this running balance looks different because we're starting with negative $1,500,000. Notice here that with this firm, we have a value of $1,851,389 and some change. Well, if you subtracted $1,500,000 from that, you'd have $351,389, which, when we include the investment, is exactly what we have. This now is a net present value. And when you look at the spreadsheet and start to delve into the different cells in the spreadsheet, you'll see a little bit more about the coding and the terminology used. But let me back up and show you something I think is important to you here. Notice that when we opened up any one of these cells, we didn't see any numbers. All we saw in any of these were formulas. That's because I put all my variables up here in a little table, and then these cells simply pull from these variables, such that if I decided, what does this look like at a 9% rate, I can go ahead and say, let's make that 0.09, and it's going to change all of the numbers. Or what if I'm going to think about a 15% growth instead of 16%? What does that do? It changes all of the numbers. So this lets you do scenario analysis, and you can even use this kind of a model structure to do some sensitivity analysis by putting in some variable values and see where your analysis starts to fall apart. And sometimes it does, and frankly sometimes it doesn't. It just depends on what kind of a model you're dealing with. So I'm putting these back to the numbers they had a moment ago so that we can compare them to some of the some of the other numbers we've got going on here. I didn't do some of that right, so let me back up and do it again. That was 0.08, and this is 0.0 or 0.16, and then let me go back up. Excuse me. At 0.16, and now we should be back at some of the numbers that we were looking at earlier. Yeah. So here we have it without the investment, which creates a present value. Now we're looking at it with the investment, internalized, so it's endogenous to the equation, and we're looking at a net present value. Now I've run a internal rate of return here. And we might have argued earlier that we couldn't reasonably do that because it's inclusive of this continuing value, which gives us some perpetuity construction. But remember, this value was as of a particular point in time. And so we were able to think about creating an internal rate of return in this column, or from the values in this column. And we know that the internal rate of return is greater than 8%, because our R is 8%, but we have a positive net present value. So it doesn't surprise us that we have an IRR that's possibly 9.51%. We know that we're getting $351,389 and some change more than the 8% rate of return would provide us. So in this next sheet, all I've done is I've shown these to you kind of side by side. It's the exact same set of numbers, the exact same metrics, everything is unchanged. So let's go ahead and show you what this might look like with respect to using it for Lesh-Cal. So here's a spreadsheet for Lesh-Cal. And in this spreadsheet for Lesh-Cal, all I'm doing is I'm replicating the material I have over here in the upper right for Lesh-Cal Industries. And here, remember, we have some income variable that we're starting with. I think it was 21.8 cents per share. And we're saying in the years 1 through 5, that's not going to grow. It's going to stay 21.8 cents per share. So its growth is 0. And then in years 6 through 10, we have it growing at a 10% rate. So all I'm doing here is every year I'm expanding it by another 10%. Each of these cash flow variables then that are my numerators are discounted for each of these two explicit periods, 1 through 5 and 6 through 10. Each of them are discounted by our 6% discount rate. And then we take a continuing value, which is D at time 11, or time 1, if you will, to give us a continuing value at time 0 divided by R minus G. And here we've taken the value of 0.218 times 1.1 to the 5th, which is exactly what we had here in our 10th year's numerator. And we've now expanded that by another 3%, because that's our longer term G in this case, in the case of the scenario in Lesh-Cal, and divided by R minus G until it brings us 12.054 for the continuing value. That value lives 10 years into the future. So in the next set here, we're discounting it back, and then we're adding them together. Well, that's exactly what we're doing here. In this case, we're doing it, we don't have an investment put in here, but notice that we've got these income values, and they are expanding each year by 1 plus G, which G is 0, so they're just expanding it at 1, which is no expansion at all, until we get out here to year 6, and now they're expanding at 1.1 for each of the years until we get down to year 10, and that creates our explicit period then. And our continuing value, just as you saw on the other page, is our income value in year 10 expanded at the 3% divided by R minus G. But because that value lives in the future, we're going to go ahead and discount it back by taking the value and discounting it by 1 plus our discount rate to the power of 10, because that's the number of years we're dealing with. And then we have, excuse me, we have this running total just exactly as we had in the example for propensity. And once again, we're just replicating the numbers here and doing the exact same thing we did in propensity. Now in this case, I know that this value is 8.5608. I calculated it that. So in the next set over here on the right, where I'm accounting for some kind of an investment, I've said, all right, what if I paid 8.5608 for this? So that money came out up front. I now get that cost juxtaposed to these benefits, discounted at the rate over time to the running total, and I add it all up, and I've got a present value of the discounted cash flow, which is negative still, and then I've got my continuing value of the dividend based on the dividend growth equation. I bring that to a present value, and it gives me then a sum of the present value of the discounted cash flow plus the present value of the continuing value is going to equal 0. Notice in this case, and this is a bit of a rarefied case, I'll admit, where we have the negative being exactly equal to the positive, so we have 0. That's because we used exactly the 6% rate in order to do our discounting, and that gave us our value from the column here. We didn't have the investment. So my net present value is 0, and when we have a net present value of 0, remember that that means we got exactly what our expected rate of return was. If I had given us something such that our net present value or our discount rate was, let's say, let's say it's going to be 14%, which is kind of a big number as it turns out. Now look, we don't have 0 anymore. Now we have a pretty meaningfully negative value running here. If we think that these cash flows are going to get this thing done for us at a 14% rate, well, we're sorely mistaken. We have a negative net present value, which means that our actual rate of return was less than our required rate of 14%. Or if we similarly change this to, let's say, 0.05%, then let's see what we've got going on. Well, we end up with a positive net present value, which we know means that we got more than that. Well, we know that we got more because remember, what we were getting was 6%. And if we say we only need 5 and we got 6, then we're going to have a positive net present value. So this is a little bit about how I've constructed this. As I've gone on, I've simply then run some bond calculations based upon the metrics that you understand. I think the wording here probably is self-explanatory for you. I then am looking at another set of discounts, in this case based upon a different income variable. I'm no longer looking at the dividend alone of 21 cents. I'm now looking at, I believe it was net income of 66 cents. I'm expanding those by the exact same G's. I'm applying the discounting of the exact same R to them, and I come up with a very different value. And hopefully as you read through this, it'll make sense. Now, what I haven't done is giving you any indication as to how to solve number 5. So I want you to think about this. If I know that the enterprise value of this company, which we've identified here in number 2 as being $9,882,000. If I know that's enterprise value, and if I know that enterprise value should be roughly equal to the valuation that we calculate, and if I know I'm going to want to use all the income as we're using here, then at some potential R, this set of calculations will come out to $9,882,000. So run this kind of valuation here and see at what R does this give us a value of $9,300,000 or whatever it was in my $9,800,000. I think you're going to find that it's more than the rate of 6%. I'm going to take this back to 6 where it was, so we can have that baseline again. I think you're going to find it's more than 6%. And my guess is that you're going to find it's probably something more along the lines of 10.5%. When I put in 10.5% for that, I get, well, no, I've gone the wrong way, so that's not it. It's some other number. Actually, the reason it's not it in this case is because I'm still using this is the income variable. If I change this to 66 cents to replicate the other analysis, now look at this. I'm $9,824,000. That is not substantially different than the $9,882,000. So I'm honing in the rate for R that the market must be using for this firm in order for that to really be the enterprise value based upon this kind of a metric is going to be about 10.5%. You will want to hone in on it a little bit more finitely. You want to create the tables. You want to replicate them here for me, copy and paste them from your spreadsheets. But this will give you an idea as to how I went about putting that together. If you have any questions, don't hesitate to let me know, and I'll see if I can help you with them.